Okay, the first video we're gonna talk about very briefly the HDFS, Hadoop Distributed File System. Okay, I'm on my screen is chapter 3 of our textbook, so I'm gonna basically use this to present. Okay, HDFS. To spell it out is called Hadoop Distributed File System. Okay. HDFS is the second, okay, components of Hadoop. We already talked about MapReduce. Okay, already play a game of MapReduce. Hope you have a good understanding about how MapReduce works. Now we're going to talk about Hadoop HDFS. So MapReduce was the programming model, and HDFS is the file storage system. Okay. File storage system basically means where do you save your file. Okay. And Hadoop has a very special design to handle file storage. Okay, because it was designed for a large file, we call so-called big data. Okay, so we're going to talk about very briefly about what it is, the design features, and following that, I'm going to use several other videos to explain how HDFS is different from the traditional file storage system. Okay. So let's get started. First, HDFS is called is kind of a distributed file system. Okay. So what is distributed file system? The textbook gives a definition. Okay, to manage the storage across a network. Okay, if I'm asked to explain it, that means your file will not be saved on one machine or on one location. So imagine in front of me there's a computer. Okay, I think everybody of you watching this lecture will be in front of you. There's a computer. Okay, and all your file, if you say work with that computer to edit a file, and your file are very possibly going to be saved into your computer, then that is one location. So if I have your computer, I have your file. Okay. Distributed file system means, okay, I have a file, I want to save it somewhere, but my file will not be saved in only one location. Okay, imagine if I use HDFS to save my file, I upload my file, and in front of me there's a network of computers, multiple computers in front of me. So where is my file? I don't know. My file can be split into several parts, and every machine holds one part. So distributed file system, the feature of distributed file system is that your file, whole contents of your file will be distributed over multiple machines in the network. Okay. Why HDFS was designed as a distributed file system? There are many good reasons. So we're going to explain that later. This part mentions part of the reason, okay, failure tolerant, okay. So we're going to explain that later. Very commonly, people call it HDFS. So this is Hadoop Distributed File System. In short, people call it HDFS. Okay. The relationship between HDFS and Hadoop system. Okay. So, as I said before, Hadoop system is not one single software. There's a multiple software. Okay. The most important, the fundamental components, we say there are 3 of them. Okay. MapReduce, HDFS, and Yarn, Y-A-R-N. So this course was designed to let us understand, get familiar with the 3 fundamental components of Hadoop system. When we call Hadoop system, usually they have these three fundamental parts. On top of the fundamental parts, we have multiple applications built on top of it. Okay, Spark is a very well-known system. Okay, the relation between HDFS and the whole Hadoop system is that HDFS provides the file storage capability, so Hadoop can run. Okay. Now, the question is that does the user have option to replace HDFS with other traditional file system? Okay. So if I want to run my Hadoop, can Hadoop run MapReduce and Yarn, and at the same time I'm using an online storage as a file system? The answer is yes. Okay. So HDFS is built in the default file storage system to Hadoop. But if you run a Hadoop, Hadoop does have an option to choose another file system. Okay. So it's a general purpose file system. Okay. So you can use local file system and Amazon S3, which is online cloud file system. Okay, the design of HDFS. We want to know the design features, several general design features of HDFS. In general, there are three. Okay, we're going to explain one by one. So this sentence put all the three features in one sentence. But if you split it, HDFS was designed for the three purpose, not purpose. We can call it purpose, but these are the design features. Okay. First, very large files. HDFS, the file system, was designed to handle very large files. Okay. So it solved the problem for you have a super large file, which is very common right now nowadays. Many companies suddenly find out, well, my server log file was too large. It was 100 gigabytes. Okay, it's very hard to put into my computer. Like my laptop in front of me has maybe 1 terabyte storage space. If you have a solid state drive, it probably 500 gigabytes is a commonplace. But if you have a file that file, the size of the file is bigger than your disk capacity, then you have no way to store it. If you cannot store it, there's no way to analyze it. So HDFS was designed to say, okay, we will handle very large file. Okay, that's the purpose. Second, streaming data access. Streaming data is a data pattern or a usage. The feature is that you write once and read many times. Okay, if you imagine that, like I record this lecture and upload it to Missouri State media server, and then many students of you gonna watch it. So I prepare to upload once, put it there, and it will be read many times. This pattern of data usage is called streaming data. Okay, please don't get confused between streaming data and low latency. We're going to talk about low latency later, but they're related. Streaming data simply means the data was saved once and read many times. Okay. Low latency means it needs, when the data was read, it requires short response time. Okay. So HDFS was designed for streaming data access. If you have a data that looks like the user used the data in a way that the data was saved once, but was right there put there once, and it's going to be read out many times, that's called streaming data. Third, commodity hardware. So Hadoop HDFS system was designed to use non-expensive, okay? Hadoop does not require expensive, highly reliable hardware. Okay. First, your hardware does not have to be very expensive. The traditional server hardware is really expensive. Okay? There's no other choice. You have to buy it or not. But if you run Hadoop, you can use surplus PC. Okay, many organizations have surplus PC. That the PC has been after it's been used for 2 years, it's too old. People are ready to get new ones. The surplus, you can surplus those used PC and put them together as a pool and make a HDFS system. So that's the third feature of HDFS. You can use commodity hardware. Actually, that's what I'm trying to do. Missouri State, that our department, we have many surplus PC. Okay, our computer lab, after several years, the whole computer lab will be replaced by the new PC. So the old PC will be surplus, and where those PC go, I don't know. But I asked our department head, I said, well, can I use them to make a Hadoop cluster? Before the spring break, I work with Jason, which is the COB computing colleague. We're trying to set it up, the Hadoop server, but haven't get it done yet. I hope probably next semester I can have it set up so we can have a Hadoop cluster built with surplus PC, which is that goes to the commodity hardware dimension. Highly reliable. This part, okay, it says your HDFS system, the hardware, does not have to be highly reliable, but it does not mean highly reliable hardware is not good. Okay, it only means your Hadoop or HDFS can still run even though the hardware is not highly reliable. In contrast, you have a traditional way build a server, then your hardware has to be really highly reliable. Okay. So these three things are what HDFS are good for. So what HDFS are not good for? HDFS is not a good fit when your data patterns look like this. Your usage looks like a low latency data access. Okay, the user wants a system that when they submit the request, the system is going to respond immediately. That's a low latency. Then HDFS is probably, so far at this moment, is not a good fit. But when you add more features to it, it can be made a low latency. Okay, but HDFS itself is not designed for low latency. Lots of small files is not good fit. This is easy to understand. Not good fit to HDFS. Okay, multiple writes, arbitrary file modification. This one looks like the SQL server. Okay, traditional relational database. Your operations. Okay, there's a lot of times, very often, your database needs to be updated. Okay. Arbitrary file modifications, multiple writes, and it's not a good fit to use HDFS. Okay, so this video is very briefly start about talking about HDFS. So we're gonna do more videos. So we're gonna stop here.